All right, hi guys. We're on our final lesson for this unit, and it is using proportional relationships. And pretty much today is all about converting. So we're just going to start with some simple conversions. These are all in feet and inches. 6 feet 3 inches, 5 feet 2 inches, 4 feet 11 inches, and we're going to change those into decimals. So the first thing we have to know about feet and inches is how many inches are in a foot. And we know that there are 12 inches in a foot. So if it's 6 feet and 3 inches, that would be 3 inches out of 12. Okay, so what we're going to do is we're going to convert 3/12 into a decimal because we already know it's 6 point something feet. So 6.312. I know what 3/12 is, but when you do 3 divided by 12 in your calculator, you get your decimal of 0.25. 3/12 is 1/4. So 6.25 feet when you convert it into a decimal. So for today, you will need your calculator because we will be doing some conversions that require decimals. So make sure you have that with you. Let's try the next one. 5 feet, 2 inches. So this would be 2 out of 12. So it's 5 point. We need to figure out what is 2/12 in our calculator. Well, 2 divided by 12 is 0.6 repeating. And what we're going to go ahead and do is round to two decimal places. Sorry, I said 0.6, 0.16 repeating. Round to two decimal places, 0.17, because the third decimal place will round. It's 5, 6, 7, 8, or 9, and it is a 6. So we're going to round this up to a 7. So 5.17 feet. And 4 feet 11 inches, so 4 feet and 11 out of 12 is what we need to calculate. Uh, 0.916, and again, the third decimal place is a 6, so it rounds this up to a 2. So 4.92 feet. Okay, now that we have some practice converting to decimals, we're going to apply that in this next problem, problem number 2. Tyler wants to find the height of a telephone pole. He measured the pole shadow and his own shadow and then made a diagram. What is the height h of the pole? So here is our telephone pole labeled with a height of h. We see that his height is 5 feet 9 inches. His shadow is 7 feet 8 inches. The telephone pole shadow is 38 feet 4 inches. So let's go ahead and convert these into decimals just like we did in the previous three problems. So 5 and 9/12. So we're going to go ahead and go to our calculator and figure out what is 9/12. 9 divided by 12 gives us 0.75. So 5.75 feet is his height. 7 feet 8 inches, so 7 feet and 8 out of 12 inches, so 8/12. 8 divided by 12, and our calculator is 0.6 repeating, and we're going to go ahead and round this to 0.67. So 7.67 feet. Okay, and the length of the shadow of the flagpole is 38 feet and 4 out of 12. And when we put that in our calculator, 4 divided by 12 is 1/3, which is 0.3 repeating. So it does not round up, so 0.33 would be our decimal here. So 38.33. Okay, so then when we don't know our height, so we're going to go ahead and set up our proportion. Okay, the height of the man and the height of the flagpole correspond. So the height of the man is 5.75, and the height of the flagpole, we don't know, is h. And the shadows also correspond. So the shadow of the man is 7.67 over the shadow of the what is that? Telephone pole is 38.33. And then we go ahead and do our cross multiplication. All right, so we have 7.67 times h and 5.75 times 38.33. Go ahead and calculate that out. 5.75 times 38.33 is 220.3975. We're not going to round yet. We only round at the very end because we want the most accurate answer possible. Then divide by 7.67 to get h by itself. So go back to your calculators. 220.3975 divided by, let's see what I divide, 7.67 will give us, so it's going to be about 28.74 feet. 28 points. And notice we need to figure out in inches and feet, and we just got our feet answer, 28.74. And remember, if we want to convert that to inches, there are 12 inches in a foot, so we just take our answer and multiply it times 12. So 28.74 feet times 12 will give us about 344.88 inches. Let's round that to a whole number, 345 inches. So lots of conversions today. Okay, one more problem on the front. A free fall ride at Six Flags casts a shadow 43 2/3 feet long. So here's our ride. I have no idea what it looks like. That's a really horrible picture. Let's undo that. Okay, I'll just pretend like this is our ride. It's just a tall building. Okay, and it's going to cast a shadow that is, it's another bad line. Let me make a straight line here. Here we go. So here's our shadow, 43 2/3 feet long. Okay, let's label that. We don't know the height of the ride though. And then there's a man who is 6 feet tall, standing. Okay, so let's draw the man. Here he is. My awesome picture. He's 6 feet tall. And he casts a shadow that's only 2 feet long. Here's his shadow. And that is only 2 feet long, so let's label that as well. Okay, so we have the heights and the shadows of both of our figures, so we're going to go ahead and set up our proportion to solve for the height of the ride, which I've labeled with an X. So the height of the ride corresponds with the height of the man, and that's equal to the shadow of the ride. Okay, we're going to go ahead and convert 43 2/3 into a decimal. At this point, you should know that 1/3 is 0.3 repeating, so 2/3 is 0.6 repeating. So then I'm going to go ahead and round that to 0.67. 43 2/3 is 43.67 over the shadow of the man, which is just 2. Okay, we're going to cross multiply. 2 times x is 2x. And then 6 times 43.67 is 262.02. And then go ahead and divide by 2 to find the height of the building. 262.02 divided by 2 equals 131.01. And we want it in feet, so let's just leave it as a whole number. 131 feet tall is the height of our Six Flags ride. 131 feet. That's the nearest foot. Okay, there is a couple of fill in the blanks here at the bottom. You do not need to know these last two blanks. I'm just more concerned that you know what the top part is. Let's go ahead and read it. A blank blank represents an object as smaller or larger than its actual size. That would be a scale drawing, like a map or something like that. A scale drawing represents an object as smaller or larger than its actual size. The drawing scale is the ratio of any length in the drawing to the corresponding actual length. Okay, so we're going to go ahead and look at one of these problems on the next page. Okay, on a Texas road map, Kristen measured the distance of 11 and 1/8 inches from Dallas to Tyler. Let's go ahead and figure out what 1/8 is on our calculator so I can put it as a decimal. 1 divided by 8 is 0.125. Okay, so this would be 11.125 inches from Dallas to Tyler on our map. The scale of this map is for every 0.5 inches. In real life, it's 6.5 miles. What is the actual distance between Dallas and Tyler to the nearest mile? So we're going to make sure we keep things in line here. We're going to do inches on top and miles on bottom. We know that in our map it says that Dallas to Tyler is 11.125 inches, but we don't know how many miles that is in real life. But we know that the scale in our map says that for every half an inch or 0.5 inches, that is in real life 6.5 miles. So we keep inches on top, miles on bottom, and we have our proportion, and we're ready to cross multiply. Okay, 0.5 times x is 0.5x, and then 11.125 times 6.5. Let's multiply that out in our calculator. 11.125 times 6.5 is 72.3125. 72.3125, and then divide that by 0.5. Again, calculators are a must on this lesson because you're dealing with lots of decimals. So 72.3125 divided by 0.5 gives us 144.625, right? And it's asking us to the nearest mile, so nearest whole number. And 144.6, that 6 will round the 144 up to approximately 145 miles between Dallas and Tyler. The last two problems on here we're going to save for class because we're going to use an actual map and figure out the distance between Berkner and Apollo and Liberty and other things like that. But we're going to do that activity in class. So I'll see you guys in class soon.